I am Carl Friedrich Gauss, born in 1777 in Brunswick, Germany. My family was poor. My father worked as a gardener and laborer, and my mother was illiterate but deeply supportive. She never recorded my exact birth date, only that it was a Wednesday, 8 days before the Feast of the Ascension. I later calculated it myself, April 30th. From a young age, numbers weren't just schoolwork, they were clarity. At the age of 3, I corrected a mistake in my father's arithmetic. By 7, I had stunned my teacher by instantly summing the integers from 1 to 100 using a trick I devised, pairing the numbers from both ends to always make 101. My gift didn't go unnoticed. The Duke of Brunswick sponsored my education, allowing me to attend the Collegium Carolinum and later the University of Göttingen. Those years shaped me. I proved the fundamental theorem of algebra at just 22. It states that every non-constant polynomial equation has at least one complex root. I gave not just one proof, but 4, each more elegant than the last. At 18, I discovered that a regular 17-gon could be constructed using only a compass and straight edge, a feat that hadn't been done since the time of the Greeks. That work inspired my lifelong fascination with number theory. I didn't seek fame. I preferred precision. Many of my discoveries stayed in my notebooks, unpublished, because I didn't feel they were perfect yet. The Disquisitiones Arithmeticae, published in 1801, was the one book I poured my heart into. It laid the groundwork for modern number theory. That same year, astronomers lost track of the dwarf planet series. Using a method I developed, least squares regression, I predicted its location with astonishing accuracy. Within days, they found it exactly where I'd said it would be. I married Johanna Osthoff in 1805. We had 3 children, but tragedy struck. She died giving birth to our 3rd child, and that child too died shortly after. I was devastated. I remarried a year later to Minna Waldeck, and we had 3 more children. Yet loss came again. Minna passed away in 1831. After that, I withdrew even further from public life. My collaborations were rare but profound. With Wilhelm Weber, I developed the first electromagnetic telegraph. We also helped pioneer the field of magnetism, which led to my name being given to the unit of magnetic flux, the Gauss. In geometry, I questioned whether space was truly Euclidean. I explored non-Euclidean possibilities. Even though I didn't publish those thoughts, they were too radical. It was only later that others like Lobachevsky and Blee brought those ideas forward. One of my most beautiful equations connects 5 of the most fundamental constants in mathematics. E caret, I pi, plus 1 is equal to 0. I didn't invent this formula, that was Euler, but I revered it. It reflected the kind of deep symmetry I lived to uncover. I also introduced the Gaussian distribution, or the bell curve, which became fundamental in statistics, error analysis, and probability theory. Throughout my life, I resisted teaching. I rarely lectured. I believed that only a few truly understood mathematics at its core. But I wrote extensively and mentored a few, including Richard Dedekind and Bernhard Riemann, names the world would later know. I passed away in 1855 in Göttingen. They cast my brain in plaster to preserve the shape of genius. I would have hated that, but if I left anything behind, I hope it is this, a glimpse into the hidden harmonies of numbers. I did not discover mathematics. I merely uncovered what was already there, written in the language of the universe.